Hello and welcome. So today we are handling projection and directional cosines. So it's still under vectors basically. So we have a question here, and our question says find the scalar projection of the vector A, which is I minus 2j plus k, to the vector B, which is equals to 4i minus 4j plus 7k. So the first thing is to give the formula for the scalar projection. So if we are projecting A onto B, so we are writing B, we have A is equals to vector A times B hat. Remember, we say that B hat or anything hat is unit. And how do we get a unit vector from our previous lesson? You divide the vector by its length or magnitude. So that's how you do it. So this is basically, you can decide to get it as A dot B over B. You can use any sign. So let's use uniform signs. So you can decide if you're using the arrow, you use the arrow all through. So let's change to the arrow, the both of them apply. And now that's our formula for getting. So the first thing you can start with, you can either go the other way of getting the unit vector first and multiplying, or you can go the way of getting the dot product. You choose the direction you want to take. So here let's use this, our B. We're going to find the distance. So we're going to solve using both and see. So B is equals to the square root of, we have 4 squared, which is 16, negative 4 squared, which is 16, plus 7 squared, which is 49. 49 plus 32 gives us 81, which is simply 9. The square root is 9. So if we divide here, we're going to get B star is vector B over the norm of B, which is 4 over 9i minus, so this is minus 4 over 9j plus 7 over 9k. So that's our vector, our unit vector. So our next step is to multiply it by A. So we have A dot B hat, which is simply, our A is I minus 2j plus k dot 4 over 9 I minus 4 over 9 j plus 7 over 9k. Remember, I dot I is equals to j dot j is equals to k dot k is equals to 1. So we're going to get this, and it's a scalar product. So I'm going to get 4 over 9 plus, because this is minus 8 over 9 plus 7 over 9, and our scalar projection is 19 over 9. So you can decide, or you can use the other method. So this, if you use this value, you are getting 19 over 9. Alternatively, we have the norm of b is 9. You can get the distance, this one magnitude is 9, so you can get a dot b and see if our value will be the same. So we are saying or, so we want to use this formula, a dot b over, and see if it still gives us the same thing, which must give us, so this is the projection of a on b. So we're going to get a dot b, and a dot b is, we have I minus 2j plus k, we are multiplying by 4I minus 4j plus 7k. So here we are going to get 1, so this one will be 1. We're taking the coefficient -2, 1, 4, -4, 7. So if you get the dot product, it's 1 times 4 is 4 plus 8, -2 times -4 plus 7. This gives us 19. So after we get 19, that means we're going to get a dot b over the magnitude, and a dot b is 19, magnitude is 9. That's the scalar projection. So it's simpler if you use method B. Okay, on to the next. We have the directional cosine. So I'm just going to give the formula, or let's use a problem to denote that. So determine the directional. So we have here an exercise, and this one is on directional cosine. Directional cosine. So we're saying determine the direction cosine and direction angles. So if you can get the cosine of course, you can get angles. So these are direction angles. We have forgotten the word direction here. For a is equals to 2, 1, -4. So our first step is to find the, so let me just remind you the formula. So this one is alpha, beta, and the other one is gamma. So we are saying cos alpha is a1 over the norm, the distance of a1 over the distance of a, not a1, over the distance of a. This is misleading. Let me just delete. Over the distance of a. and then cos beta will be A2 over the norm of A, and then cos gamma or cos, I don't know what that is called, A3 over the distance of A over the distance of A. And this is because if you multiply AI by I, you still get A1. If you multiply by J, you get A2. If you multiply by K, you get A3. So in our case here, we're supposed to get the norm, the distance. So another name of distance is just norm, but we're going to use the name distance. The distance of A will be 4 plus 1 plus 16. This is the root of 21. And now we have cos alpha will be equals to, our A1 is 2 over root 21. So these are the direction cosine. Our next direction cosine will be cos beta, which will be A2. A2 is 1 over root 21. And our last direction cosine will be negative 4 over root 21. So those are the direction cosines. If you want to get the direction angles, you just get the cos inverse of here, cos inverse, cos inverse. You're going to be left with alpha is equals to 64.21. Here you will get beta or beta is equals to this, depends on the English teacher, 77.40. These are degrees, and now here you're going to get, I think it's gamma or delta n, I don't know, which is equals to 150. I think you're going to get 150 because you know it's a negative, and so you're going to get the other. You're going to use your trigonometric skills here. So you're getting 150.79. So those are the direction angles and the directional cosines. Thank you. And now I have an example for you, and this one is left for the reader to practice. So this one is an exercise. Find the direction cosine and direction angles for 2, 3, 1. So try that out and reach out if you experience any challenge. Thank you for joining us, and bye.